Hello everybody, welcome to today's lesson when we're going to talk about exponent properties, and more specifically, out of those properties, the ones with rational exponents. So we already know what an exponent is. Let's go ahead and break down what a rational exponent is. If we look at the first few letters of the first word, that's ratio. What a ratio is a fraction. So rational means fractional exponents. Like x, and the easiest fraction we have, since one of the most simple numbers we have is 1, the easiest fraction we have is cutting the number 1 in half. So let's go ahead and see and think about this. In the past, whenever we've been doing x squared, that means we're going to do x times x. That's what we're teaching. When we're doing x cubed, that means x times x times x. That means it happens 3 times. So if I have x to the power of 1/2, does that mean we're going to have half of an x? Like I just drew the left side of an x. Because you already know that x to the first power is x. X to the 0 power is 1. So what's going to happen to the power of x whenever you're between the numbers 1 and 0? Do you just get half of an x? No. What happens whenever you have a fractional power is, take a look at these powers that are not fractions first. This is the whole number 1. These are whole numbers. So even including 0, whenever you have a power and it's the full number, x squared, x to the power of 3, x to the power of 1, x to the power of 0, those are whole numbers. And those whole numbers means we are multiplying things. We are multiplying things, and normally we end up getting larger numbers. So whole number exponents mean you have to multiply repeatedly. So if we go back to that x to the 1/2, we can break the number 1/2 into 2 separate pieces. You have the numerator and you have the denominator. When you break that exponent into 2 separate pieces, the numerator and the denominator, what the denominator does is the denominator tells you what is the root that you're going to do. Since the denominator is 2, that means we are going to do a square root. That top number, what the top number tells you, the numerator of the fraction, is that tells you what the power of what's going inside that square root is. The power of what's going inside is the power of 1. So the top number tells you the power, and the bottom number tells you the root. Go ahead and write that down. In a fractional/rational exponent, the numerator tells you the power, which is the normal thing, and the denominator of that exponent tells you what the root is that you need to use. So just to surprise, there is more than just a square root. A square root can look like that, or a square root can look like this. If you have the number 2 there, or if you have the number 2 not there, these are square roots. You could have a cube root. A cube root would be the same symbol, but with a 3 on the outside of that symbol. Or you could have a fourth root. And that would look like the number 4 on the outside. You could do the cube root of a regular number, like 27. The cube root of 27 is the number 3. You could do the fourth root of a number, like the number 16. And the fourth root of 16 would be 2. You could do the square root of a number, and that would be the square root of 4 is 2. So the key thing to know is that different roots, different types of roots, square root, cube root, fourth root, nth root, it comes from, it looks like this. The number that the root is taking goes on the outside of the radical, and it comes from having a variable or number raised to a fractional power. So let's just get some more examples. 2 to the 1/2 power is equal to, the top number is 1, so that's 2 to the first power. The bottom number of that fraction is 2, so we're going to make a root. Since there's a fractional power, that means we have to make a root. For every fractional power, you have to make a root. And outside of that root is going to be the number 2, because that was the bottom number. The bottom number goes outside the root. The top number goes inside as a power. Well, it could go inside or it could go outside according to the order of operations. And let me just show you. 3 to the 1/2 power would be equal to a 2 on the outside, a square root of 3, and that top number, that power, the number 1, you can, if you wanted to, put it out here. The reason why it's okay for you to put it out there is because it'll just distribute back inside, and that would be equal to the square root of 3 to the first power. So if you want to, you can put that number 1 out here, or you can put it right there. The reason why you have to keep track of which number is the top number, the power, and which number is the bottom number, the root, is because you can have something that has a power and a root. For example, you could have 27 to the 2/3 power. If we change that, the number 27 is being raised to the power of 2/3. 2 is the top number, so that means we have 27 squared. 3 is the bottom number, so that means we have the cube root of 27. And if we have a calculator, you could figure out 27 squared and then take the cube root. Or I already know what the cube root of 27 is, so I'm going to do the cube root part first, and then I'm going to square that answer. The cube root means what number, let me just write that off to the side so that you can write it too. Cube roots are asking what number times itself 3 times makes 27. What number times itself 3 times makes 27? And that answer is 3. So this inner piece here, the cube root of 27 makes 3. But then we have this exponent on the outside, which is a power of 2. And then 3 squared is 9. That means that the 27 to the 2/3 power is equal to the number 9. Or it's equal to the 3rd root of 27 squared. So let's go ahead and write that in our notes down too. This is read as the third root of 27 squared. Let me do a few more examples, and you can do them with me. Okay, here are 4 examples. 4 numbers that are raised to a fractional power. What does the top number mean? The top number is the power. What is the bottom number? The root. So the number 4 on the bottom means the 4th root of 2 to the first power. The number 1 on top of this next one, the number 1 is the top number, so that's the power. That's 100 to the first power. The bottom number means a root, and that's a 2, so that's the square root. We can simplify this a little bit. The 100 to the first power is just 100, and the square root is a normal square root, so the square root of 100 is the number 10. Up here in the first example, we could simplify it just a little tiny bit. 2 to the first power is 2, and we can leave the 4th root on there. Figuring out the 4th root of 2, it's not going to be a perfect number. Has an imperfect answer, which means no number, well, no whole number, no whole or rational number times itself 4 times makes the number 2. If you put the 4th root of 2 in a calculator, you will get an answer, but it's not going to be a clean answer. It's going to be a never-ending decimal, which is an irrational number. So we just leave it as the 4th root of 2 because that's the only neat way to answer it. The square root of 100, though, this is a perfect root. You could say perfect square root, but there are other numbers that have perfect roots, like this one. This would be the 4th root of 81. That means what number times itself 4 times, that number multiplied by itself 4 times makes 81. Question mark? Well, we figure that out by doing a factor tree like we did the first day back from Christmas break. If we turn this 81 into its factors, then we can find out what number times itself makes 81. If we break this down to its factors, 81 is 9 times 9, and 9 breaks down to be 3 times 3. This other 9 also breaks down to be 3 times 3. 3 is a prime number, so that's as low as it can go. That's as low as this factor tree can go. So 3 times 3 times 3 times 3 makes 81. 3 times 3 times 3 times 3 is the same thing as writing 81. What's being highlighted right there, those two numbers are equivalent. Now, since we rewrote 81 as 3 times 3 times 3 times 3, we can change that to be 3 to the 4th power. And we're still doing the 4th root because that's what the original question wanted. So we started off with the 81 to the 1/4 power. 81 to the 1/4 power means the 4th root of 81. If you change the way 81 looks by using its factors, by using the prime factors, that's the easiest way to do it, but you could use other factors. We changed 81 to be 3 times 3 times 3 times 3, which is also a number that we used yesterday. Once you have all those 3's, you can change those to look like an exponent, and that exponent is a power of 4. And now, let's just take a look at this. This power of 4 is a power. This one on the inside, that's a power. So that's going to go on the top. Then this 4 on the outside is a root, so that's going to go on the bottom. So when we have 3 to the 4/4 power, 4 divided by 4 is 1, And 3 to the first power is 3. That means that if we take these two sides of that equation, we have 81 to the 1/4 power is equal to 3.